Hi there guys, and welcome to this video on indices, but paying particular attention to the negative powers now. So negative numbers, they really came about by looking at patterns and just being curious what happens when we get to zero. You know, there was a point in time that negative numbers didn't exist. There was a point in time that zero didn't exist. But if we look at what we should already know, I'm pretty sure you know 10 times 10 times 10, or 10 cubed, is 1,000. If you didn't know that, this isn't the video for you. And 10 squared is 100, and 10 to the power 1 is 10. And at this point we started to notice the pattern between these, and you can see clearly we're dividing by 10 every time. And anything to the power 0 is also 1. So when we continue this pattern here of the powers, it naturally leads us to 10 to the minus 1. Well, if we continue this pattern, it brings us to 1 divided by 10. Now, lots of you out there will go for 0.1. Decimals are never a good idea. They're so difficult to see patterns. Always go for fractions. Now, if we keep this going, we get 10 to the minus 2, which is 1 over 100 if we divide by 10 again. It's the same as times in by 1/10. And if we do it one last time, we get 10 to the minus 3, and we end up with 1 over 1,000. Now, when we looked at this, we thought, well, this is also the same as 1 over 10 squared, and this is also 1 over 10 cubed, and this one is 1 over 10 to the 1. And now you should be able to make the connection between the blue and the purple. It's strange, but it should be quite obvious how you can see it. So if 10 to the minus 3 is now got a 1 on the top, in fact they all have a 1 on the top, it's turned into a fraction, but we can see that it was a fraction when we continued the dividing by 10 process in the black line. And the power is now on the denominator, and it is also positive. That negative power is gone. I've had some pupils in the past imagine this line is the line shooting out to become that fraction line. But to go from this power form, this index form, to this fractional form. So what's actually happening here is this 10, and all of these 10s on the blue line could all be written as 10 over 1. Now you can see that when we have a negative, that 10 is now being reciprocated. Okay, so that's actually what's happening here. The 10 is just being flipped over. Now the power isn't only on the denominator. What's actually happening here is this minus 1, when we reciprocate, the power is positive. Okay, so that's why the minus 2 becomes 2 and the minus 3 becomes 3. But we only normally write the power as the denominator because anything, or 1 to the power of anything is 1. So it's not a very efficient way of writing it, but I need you to appreciate that this is the same thing. So let's have a look at some other questions. So this is what you could be asked to do. Write in a fractional form. Now I'm going to take the first one very slowly, and the second one I'm going to do quicker once you learn the technique. So this is the same as 5 over 1 to the power of minus 4. So when we see a minus power, what we're actually going to do is reciprocate. So it's 1 over 5, and the power becomes positive. It's not a rule we made up, it's a rule that we spotted actually happens when we continued those patterns on at the start of the video. So 1 to the power of 1 is 1, and 5 to the power of 4 is 625. Or we could have written 1 over 5 to the power of 4 there. So how I would personally do this, I wouldn't go through all this working here. I would just go, oh look, negative power, so it's 1 over, and the power is positive. Okay, so 1 over 3 squared. So that's a fluency step once you're there. But lots of people are confident with that, but because they don't understand this easier, well, the actual what's happening method rather than this little magic trick, they struggle when they come onto harder ones like this. And this is just a BIDMAS problem. What you've got to realize is this is the same as 2 lots of a to the minus 3. It's BIDMAS. We hide the multiplication. which is the same as 2 lots of 1 over a cubed. Exactly the same as here. I could have written, I'll do it, I could have written this, so it's a over 1 to the minus 3. We reciprocate, power is positive, 1 to the power of 3 is 1, a to the power of 3 is a cubed. So we end up with 2a cubed. So you can see, it's not always a 1 on the top. If we're multiplying by something, when you multiply fractions, you only multiply the tops by the tops and the bottoms by the bottoms. You know, for example, I could put a 1 here, for example, so it'd be 2 times 1 is 2, and 1 times a cubed is a cubed. Now, I would always advise you to do these ones a little bit slower. So that's the same. So that's 5 times 1 over m squared. So that is 5 over m squared. Now, personally, I go from here to here because I'm fluent. Don't try and make that step straight away before you understand the working. Okay, because otherwise, this one will get you. This is actually the same though. It's a BIDMAS problem. The coefficient, instead of being 2 or 3 or any whole number, it's now a fraction. So it's 3/5 times r to the minus 2, which is the same as 3/5 times 1 over r squared. So 3 times 1 is 3, and 5 times r squared is 5r squared. In many ways it's easier because you just times the tops times the bottoms. A lot of people on here, I see 2 top and bottom, but if you think about that, they would cancel, and that doesn't make any sense. So the next one, write it out, take your time. Okay, so you write the coefficient on its own. Write this indice in its fractional form, and then times the fractions together. Now if you look, the 3 was a numerator, it still is in the answer. The 5 was a denominator, it still is in the answer. 2 is on top, it stays on top. 3 is on the bottom, it stays on the bottom. You know, that's another little cheat you can do. The 2 is a numerator, still is. The 5 is a numerator, it still is. Okay? That doesn't apply for these because the base value here is 3 and 5. These aren't coefficients. I was talking there about that pattern with the coefficients because the letter is the base value. So we can also ask you to write an index form, so go backwards. We often refer to that as in the form ax to the n or kx to the n. You'll see that more when you do integration and differentiation. So 1 over 3 to the power 4 is the same as 3 to the power of minus 4. Another way you could look at it is, oh look, we've got a power on the bottom, so you have to make that connection with negative powers. So what we actually have here is that if you want to make that a minus, you just undo that process, so you reciprocate again. Okay, but you wouldn't write the divide by 1. So this one is, for the same reason, is 4 to the minus 5. So whenever I see a fraction with a power, automatically think negatives, and it's just a matter of time before you can get there. So write this one in index form. Now, this is a bit harder. So what you've got to realise, it's 2 lots of 1 over m to the 4. So we've just discussed it going from this to this, so we have to unpick it. Now, by this point, hopefully you're aware that this is m to the minus 4, so it's just 2m to the minus 4. And this one here, so it's 5 lots of 1 over a cubed to get this question. So that's 5 lots of a to the minus 3, which is 5a to the minus 3. And yes, you can go from there to there, but when you're learning, take your time. Okay, these ones are a little bit harder, but it's exactly the same, but just people can't see it. So this is 1/2 times 1 over m squared. So this is 1/2 times m to the minus 2, so it's half m to the minus 2. And yes, I go from here to here. I don't personally do any of this, but I've been doing it for years. So 3/5 times 1 over h to the 4 is an equivalent step of working, which is 3/5 times h to the minus 4, which is 3/5 h to the minus 4. The coefficient a is 3/5. The base value is h, and our power, our index, I can't think of the other word, is -4. Now here's the last question we're going to do. So the other type of wording is evaluate. It just basically means do something with it. So, look, I see a negative power. So the first thing I think about doing is reciprocating. So a lot of people would put off when they see the fraction. It's actually easier, I think, than having a whole number because you have to remember to reciprocate it. Here it's kind of obvious, isn't it? You just flop it. Oh, that is now positive. So 5 squared is 25 and 3 squared is 9. Now these are much harder, but I've got a negative power, so I'm going to reciprocate. Power becomes positive when we do the reciprocation. Now you've got to be careful because each of these parts, the numerator and the denominator, is raised to the power of 3. So the top one, we can have 27m to the power of 9. Now the reason that works, I'll explain in another video, but it's, if you think about it, it's 3m cubed times 3m cubed times 3m cubed. A lot of people keep the coefficient as 3, but they get the power right. It's this part and this part all being raised to the power of 3 for this very reason here. So 2 cubed is 8, and we have a to the power of 6. There we go. That's all you can do with that one, really, because these bases are different. We can't do any rules with indices. Okay, so best of luck everyone, and I hope you enjoy negative indices.